Hi guys, myself Jeevan C from SVC. So today's topic of discussion will be remote sensing using Python programming. So let's cover the introduction, principle, classification of remote sensing, components and application. Introduction. Remote sensing is a technology to gather information and analyze an object or phenomena without making any physical contact. This technology is used in numerous fields like geography, hydrology, ecology, oceanography, glaciology, geology. It is technology for sampling electromagnetic radiation to acquire and interpret non-immediate geospatial data. History of remote sensing. National Remote Sensing Agencies was established in 1975. National Natural Resource Management System, the launch of two experimental Earth observation satellites, Bhaskar 1 and 2 in the year 1979 and 1981 respectively. Indian Remote Sensing Satellite IA-1 in March 1988. This carried two cameras. A series of IRS satellites were launched in 1990s and 11 other operational satellites. Principle of remote sensing. Detection and discrimination of objects or surface features means detecting and recording radiant energy reflected or emitted by objects or surface material. Different objects return different amount of energy in different bands of the electromagnetic spectrum incident upon it. This depends on the property of material, surface roughness, angle of incidence, intensity, and wavelength of radiant energy. Classification of remote sensing. With respect to the type of energy resource, a passive remote sensing, it makes use of sensors that detect that the reflected or emitted electromagnetic radiations from the natural resource. For example, sun's radiation, earth thermal emission, whereas active remote sensing, it makes use of sensors that detect reflected responses from the objects that are irradiated from the artificial generated energy resource, such as radar. Example, radar and LiDAR. With respect to wavelength regions, visible and reflective infrared remote sensing, thermal infrared remote sensing, and microwave remote sensing. 7 elements of the remote sensing processes: energy source, radiation and atmosphere, interaction with targets, recording of energy by sensors, transmission and reception, interpretation and analysis, and application. Components of remote sensing. Platforms to hold the instrument, a target or an object, an instrument or a sensor. Major sensors of remote sensing are cameras, microwave, radiometers, and scanners, lasers, and radio systems. Application of remote sensing. Collecting Earth's picture from space, detecting land use and land covers, observing climate changes, predicting potential landslides, computing snowpack, creating a base for visual reference, minerals and petroleum deposits, also used in agricultural field. Primary applications of remote sensing. Collecting Earth's pictures from space, detecting land use and land cover, observing climate changes, predicting potential landslides, minerals and petroleum deposits, computing snowpack, creating a base map for visual reference, for example, Google Maps. Application of remote sensing in agriculture. Identifying crop condition, increasing precision in farming, crop production forecasting, determining the soil moisture content, drought monitoring, crop condition analysis and stress detection, crop health analysis. Conclusion. With the launch and continuous availability of multispectral sensors on polar orbiting Earth observation satellites remote sensing data has become an important tool for yield modeling. Remote sensing research has identified several individual spectral band and vegetation spectral reflectance indices which have been used to detect plant water stress. Depending upon the scale at which an investigation is being undertaken, it is recommended that a particle approach to assessing plant water stress is adopted through the use of at least one ground-based measurement.